So today we're going to talk about measures of central tendency, or sometimes they're referred to as averages. There are three different measures we'll be discussing, but essentially this is just a fancy way of saying your average. So you use these a lot of times in your everyday life and you're not even really aware that you have. So an average is essentially just a way of describing the set of scores for one variable. For example, you have the ages for everybody in the classroom, and you want to know what the average age is. Well, you could list out all of the ages, and that's one way of describing all of the ages in the classroom. But the best way is describing it with one value, and that one value would be simply the average. So it's a single number that really just shows the middle of all of those scores, okay? So the first measure we're going to talk about in terms of central tendency, and it's called central tendency because you think about it as describing the middle of all the possible values that you know of. It's the first central tendency measure is the mean, the arithmetic mean, but we're going to refer to it as the mean. And for the purposes of this class, I also use the word average. So average and mean are going to be used interchangeably for this class, and you should probably have had a pretty good exposure to this analysis before, this type of analysis before in previous stats class, but we'll go over it in detail today too. So well, let's use an example where, let's say we went to Starbucks and we asked, say, 6 people how many cups of coffee they've had in, say, the last 24 hours. And keep in mind we're at Starbucks, so they're coffee drinkers. Joe has had a lot of cups of coffee. He's had 12 cups of coffee in the last 24 hours. James had 10 and Jane had 10. Whereas Chris had only 8 and Fred had 5 and Christina had 3. Okay? So there's a couple of things I want to point out to you right now, and that's that the variables in statistics are often assigned a letter value so that we can quickly refer to them, and it also just makes it sound smart. So the number of cups of coffee, or how many cups of coffee, is here in this case I've assigned the value x. X will be often used in statistics describing the value of one variable. So here we have the number of cups of coffee, which is x. So Joe's x is 12, James's x is 10, and so on. And the total number of people, or the total number sampled, or the total number of, I don't know, cars, or whatever you're looking at, in this case it's the number of students, the total number is given the value n, or the letter n. And it's also referred to as the sample size. But the n stands for number. Okay, so the total number is n. So if I ever ask you, what's your total n, if you're going to do a survey for your class, for the project, and I say, oh, what's your total n, or what's your sample size, just give me the total number of people you've asked, the survey, how many people you interviewed. So in this case, we have 6 people surveyed, and we also have 48 total cups of coffee drank. 48 cups of coffee drank by 6 people. Now, most of you would probably be able to figure out that the average number of cups of coffee is simply the total number of cups of coffee drank, divided by the total number of people interviewed. And that would be 48 divided by 6. And this is just like how we do it for, say, trying to calculate your gas mileage. If I had, this is 1 tank of gas, this is the second tank of gas, this is the third, all the way up to 6. I had 6 tanks of gas, and I ran my gas tank all the way down to 0, and this is how many miles I made it, for example. So if I made it only 12 miles, I would have had this many, miles per tank of gas. So anyway, long story short, there's a number of ways you've done this probably in daily life, and you just have not really realized it. But again, you're taking the total number divided by the n, which is 6, and that gives you your mean or your average, and that's 48 divided by 6 equals 8 cups. And by the way, we will provide you with all of these equations for your reference online, so you'll have access to all the equations you need to for future reference for any other for projects and so on. So using the same data, let's introduce some more fancy little fancy statistical symbols that only are introduced because it makes us sound smart. So again, the letter X I'm assigning to this variable the number of cups of coffee. Okay. The other symbol is this Greek symbol sigma. It's called sigma, and it's the letter S. Sigma is the letter S, and it stands for the sum in statistics world. So it's called the summation symbol. And so if you ask the sigma x, or what is the sigma x, or what is sigma x, that is simply just the sum of x. What is the sum total of x? So here I have x, and what is your sum total of x? In this case, the sum total of x is 48, right? The total of the number of cups of coffee drank was 48. And we also have the total sample size, and that's n. We've already introduced the n, the number of people. And the statistical equation written out for the mean or the average is simply the sum of x divided by n. So the sum of this column, which is 48, so the sum of x divided by n, which is 6, equals the mean, or 48 divided by 6, which gives us 8 cups of coffee per person. And last but not least, we have one last symbol for the arithmetic mean, or the mean, and that is something called x bar. X bar is simply the mean or the average described with a letter, essentially. So if I want to know the average number of x, or the average x, I'm just going to simply ask x bar. So if I assigned, instead of x to the number of cups of coffee, I assigned it, say, the letter, I don't know, D as in dog. I said, how many cups of coffee, parentheses D, instead of x. This would not be x bar here, it would be d bar. So anything with a bar over the letter is simply asking you for the average of the letter underneath it. Okay? So the mean of x. So x bar is just the average number of cups of coffee. We've already calculated that. Now we have a value, not only a value, but also a statistical symbol to assign to it as well. So the sum of x divided by n equals x bar, or also referred to as this x bar. I just typed out x bar because sometimes it's easier to type out x bar, but this x bar is the same as this x bar here. So sum of x divided by n equals the mean, equals 48 divided by 6, equals 8 cups per person, and I could even say, in addition to all that, equals x bar. So again, this is all stuff you've likely done in the past with basic arithmetic, but now we've assigned special values or special letters representing each step so that we can have a reference value for future statistics we do. So now we also have something called the ungrouped frequency distribution for our raw collected data. Okay? So essentially this is raw data. This previous table that I showed you with the names written down and the number of cups of coffee they've had. Essentially what you've done here, if you collected this survey data, was you wrote down a person's name, or likely a person's ID number. This would be 1, 2, 3, 4, 5, 6, and you've written down the number of cups of coffee they had. So that's considered raw data. It's data that are unadjusted or unfiltered or unmanipulated in any sort of way, and that's why it's called raw. It's raw data. It's not categorized in any fancy way. Here's another way of showing your raw data. You can actually make frequency distributions. So instead of having the person and then having John, Jane, Max, or whatever the names are, Ollie, Dunn, and Christina, you could actually list out the possible values of cups of coffee. So here I've listed out starting at 12 because the one person had 12. I know that because I already looked at my data. And I could go from 12 all the way down to 5 because that was the minimum number of cups of coffee drank by the people. So now, again, number of cups of coffee is still X. Nothing has changed there. But now, this number here represents the number of people that have had that number of cups of coffee. So this is actually the frequency. F here, this is another statistical symbol. F stands for frequency. So keep that in mind. So this is considered a frequency distribution. It's simply just the distribution of the frequency of people who've had this number of cups of coffee. Okay? So this is the exact same data, exactly the same data in this table as we had in this table. You see here we have 12 cups of coffee, 10 cups of coffee, 10, 6, 5, and 5, totaling a number 48. And here I have one person who had 12, 0 people who had 11, 2 people had 10, 0 people had 9, 0 people had 8, 0 people had 7, 1 person had 6, and 2 people had 5. Again, my total sample size is 6, and I have my total sample size of 6 is the total frequency. So one thing I want to point out to you here is that if you notice in my frequency distribution, I've actually listed out categories of coffee here, for example, 11 and 9, 8, and 7, which actually have a frequency of 0. Now the reason why I've done that, and I could have easily skipped them, but the reason why I do that is because I actually like to make sure that I, one, am getting all the data accurately tabulated, but number two, if you were going to try to present this in a report, and you went from 12 to 10 to 9, 8, and then down to 6, you might have the reader confused and asking what happened to 11, or was there a mistake? So in order to avoid the questions of was a mistake, you are simply just being very transparent with your data and adding a row for 0. Again, the one thing I also want to bring out to you for your attention in the big bold letters here at the bottom is the average number of cups of coffee is just not, it's not as simple with a frequency distribution. Okay? Again, in the raw data, it's very simple. You're just summing X, which is 48, and you're dividing it by the total sample size of N. In a frequency distribution, you can't sum this X because I have a bunch of values that are represented by 0, right? So this is 0, so I wouldn't want to include that. This is 0, and that's 0, and that's 0. So this sum of X does not really represent the sum of X. So in a frequency distribution, and you know it's a frequency distribution based off of the F, which stands for frequency, there are one extra step you need to take. So here is an ungrouped frequency distribution for our raw collected data. Again, this data here is exactly the same as the previous slide. I've got X here, which is how many cups of coffee, 12, 10, 11, 12, 11, 10, 9, 8, 7, 6, 5. The frequency, I have one person who had 12, 0 people who had 11, 2 had 10, all the way down to 2 had 5, okay? So the sum here of F, sigma F, is 6, right? So I've added all these up. If you add all these up, you get 6. So the sigma F is equal to 6, but it's also equal to the N, or the sample size, right? Because if you think about it, all we're doing here is capturing the number of people who had this many cups of coffee. But if you added the total number of people, that's the sample size, right? So the sigma F, or the total number of the frequency of people, is N, or the sample size. So the sigma F is equal to sample size, which is equal to the N. And the one additional step you need to do in order to calculate the mean for a frequency distribution, as opposed to your raw data, is you need to add an extra column. And you're going to call it Fx, which is simply the frequency of X. It's the frequency times X. So it's frequency times X. So here's our X values. Here's our f, or frequency values. So it's 12 times 1 equals 12. 11 times 0 equals 0. 10 times 2 equals 20. 9 times 0 is 0. 8 times 0 is 0. 7 times 0 is 0. 6 times 1 is 6. And 5 times 2 is 10. So simply, the fx is the f, or the frequency, times x. All I'm doing is multiplying this column by this column. It's a very simple arithmetic. So now I have fx, and if it's done correctly, they should add up to the total number of cups of coffee that you had in your raw data. 12 plus 20 plus 6 plus 10 equals 48. So now, for frequency distribution data, I have the sum of fx divided by n equals the sum of fx divided by the sum of f, which equals 48 divided by 6, which equals 8. So if you did it correctly, the frequency distribution calculation for mean should equal the same number as the raw data calculation for mean. And finally, there's a way to check your work. So here we have Joe, James, Jane, Chris, Fred, and Christina. Same data as before. Number of cups of coffee, x, 12, 10, 10, 6, 5, and 5, equals 48. We calculated earlier that the average number of cups of coffee was 8 across all these 8 students. X bar is the average. It means the average or the mean. So I've just added a column called X bar, and I've just entered 8 all the way down. Simply just adding a column called X bar, and I enter 8, 8, 8, 8 all the way down. And I add a last column here called X minus X bar. So it's this column minus this column equals this, okay? So 12 minus 8 equals 4. 10 minus 8 equals 2. 10 minus 8 equals 2. 6 minus 8 equals negative 2. 5 minus 8 equals negative 3. And 5 minus 8 equals negative 3. And if you did that correct, the sum of x minus x bar should equal 0. That is to say, this plus this plus this plus this plus this plus this should equal 0. And in this case, it does. 4 plus 2 equals 8. Minus 2 is 6. Minus 3 is 3. And minus 3 is 0. So this sum of x minus x bar, the sum of this column, is 0.